Hello students, today we are going to see something important and repeated question. Also, I just mentioned that important questions. Okay, now let us go for that important questions. In that first one, name the enzyme which brings about the conversion of sucrose into glucose and fructose. Okay, enzyme they are asking. Okay, now what is it sucrose? C12H22 O11 plus water molecules. It is hydrolyzing and it gives what it is glucose and fructose. What is the formula of glucose and fructose? C6H12O6 plus again fructose also the same formula. Structural formula will be vary. That you will learn in biomolecules. Yes? Okay, C6H12O6, right? Okay, now what is the enzyme? Acts as a catalyst. That is the question. Now invertase. Invertase. Okay, invertase is that enzyme which converts, which hydrolyzes with that glucose, that is sucrose converted into glucose and fructose. Hope you're clear with the first one and second one also which is related to that first one. Now the second one, name the enzyme which converts glucose or fructose, any one, glucose or fructose into ethyl alcohol. Now here what is it? Now here C6H12O6, any one, no, it gives ethyl alcohol. Ethyl alcohol, what it is? C2H5OH. So this is what is that enzyme? This is and all like informative questions like zymase. Zymase. Zymase is the enzyme which makes that glucose into ethyl alcohol. Now here invertase is the enzyme which converts sucrose into glucose and fructose. Okay, now the next question. Arrange the following. See, all I just mentioned that important. Please note down everything. I am giving that CET questions and important repeated questions only I am giving now. Okay, now arrange the following in increasing order of the reactivity. They have given some formula. So as you are looking that formula only, this is methyl chloride and this is benzene chloride and chlorobenzene, that is chlorobenzene, and this is propyl chloride. Okay, now can you write that reactivity order series? That is of course methyl chloride only will be come first, CH3Cl, and the second one propyl chloride. Yes, I can hear you are answering to that point. Okay, propyl chloride CH3, CH2, CH2, Cl. Okay, then the last one chlorobenzene C6H5Cl. Hope you're clear. Okay, we'll go some other important questions like number of questions we will see today's session. Hope you're clear with it. The next question, it's very simple and easiest one and repeatedly they are asking. Come on. Give reason why ethyl alcohol is soluble in water. So I would like to give three reasons for that. First one, number of carbonate is very less because this is ethyl alcohol, CH3, CH2, OH, hydroxyl group is present and hydroxyl group which is connected with water molecule. So what happened here? Hydrogen, this is water molecule. So second point what I would like to mention here, intermolecular hydrogen bond formation. Intermolecular hydrogen bond formation, it's very strong like brother and sister. And third one, polar, due to that polar high electronegativity. So these are the three reasons why ethyl alcohol is soluble in water. The first one, number of carbonate is very less. Number of more carbon, water it will not soluble in water. Number of carbon it is less, naturally it will be soluble in water. Second one, hydroxyl group, it is like water liking group. Okay, hope you understand that point. Water liking group, it form hydrogen bond. Okay, now third one, intermolecular hydrogen bond formation. This hydroxyl group connected with water molecule, it forms intermolecular hydrogen bond. Third point, due to that polar high electronegativity formation, it will be there. Okay, hope you're clear with this point. Okay, the next question, this is very important one. Okay, next question, name the product formed when acetyl bromide reacts with excess of methyl magnesium chloride, methyl magnesium iodide, Grignard reagent. Yes, acetyl bromide, it is like CH3COCl. Okay, acetyl chloride followed by treatment with saturated solution of ammonium chloride. Very interesting question. Come on, let us go for the CH3 C double bond O Cl. This is acetyl chloride. Okay, it reacts with excess of Grignard reagent, magnesium iodide, methyl magnesium iodide, CH3 Mgi. Okay, now what is that product you are getting? CH3 C, here CH3, this CH3 one and another one more CH3, here Br, and here what it is? O Mgi. And they mentioned excess. Yes, again it's going to react. CH3 Mgi. Methyl magnesium iodide is also known as Grignard reagent. Yes, you are getting the answer. CH3, here C, here CH3, here CH3. Three CH3 group is there. Here one, and one more here, replacing that Br. Okay, now OMG. Okay, now again, what it is? Followed by treatment with the saturated solution of ammonium chloride. So, saturated solution of ammonium chloride, NH4Cl. So, what is the product you are getting? So, here what it is? CH3, here C, here CH3, here CH3, here OH. That's all. Now, what is the name of this? 2-methyl, 2-methyl, 2-propane all, 2-propane OL all. Okay. So, this is the name of the final product. We want that only. That is what they are asking. You know, this is also important and it's very interesting. Acetyl chloride, from acetic acid, acetyl chloride, acid chloride they will say. Okay, CH3COCl. Okay, that OH group it is replaced by Cl. See, acetyl chloride, CH3COOH. So this OH group which is replaced by Cl, so this is called acetyl chloride, CH3COCl. Hope you're clear with this answer. These two answers are thorough. Now next to one more question, it's very important. The next question, name the product formed via oxymercuration of HgSO4 and H2SO4 of 1-butane. And evergreen question, it's very interesting question also. Come on, let us go for that. Here, 1-butane, YNE. So what is the formula? CH3, CH2, C triple bond CH, right? 1-butane. And it is oxidized, oxymercuration formation. Here what it is? Hg2 plus. I just take that Hg2 plus. So what happened? The bond breaks. So this bond breaks means naturally it goes there. Carbocation formation takes place. Intermediate compound. So CH3, CH2, C double bond CH2. So here Hg2 plus. Right? Here intermediate compound it takes place and it is oxidized with dilute H2SO4. Okay, now H2SO4, dilute H2SO4. So what is the formation you are getting? You are getting keto-enol formation under tautomerism. Yes, what is the product you are getting here? It is CH3, CH2, C double bond, CH2, here OH. This is enol formation. Enol formation. Okay, so what is the name of this compound? Here actually it is isobutyl alcohol, right? Okay, now this will not be quite, it gives a keto formation. So here enol keto enol formation, right? So this is tautomerism. Okay, so what is the last product we are receiving? We want that product only. So CH3, CH2, C double bond O, CH3. Right? So this is actually, what is the name of this compound? Can you give? This is ethyl group connected with methyl group, which is in between what it is? Keto group. So ethyl, methyl, ketone. So what it is? Ethyl, methyl, ketone. Okay, see, it's very, very important. Those days they have asked question wise, but nowadays they are asking option wise. Okay, four options. In that four option, they are asking that question. Another one more topic while learning. See, it is aldehyde ketone topic also. It is available. Even in this topic also, they have given this question. As we are going through these questions, no, it's very, very important, so I just bring it to your notice. It's very important and it's very interesting. Repeatedly they are asking, see that here what it is, evergreen question. So please remember and recall all these points. So this is butane. When it bond breaks with due to that oxymercuration, you are getting that keto, that what it is, intermediate compound and oxidized with that enol formation. Enol formation will not be quiet, you will get the keto formation. Ethyl methyl ketone you are getting. This is comes under tautomerism. This topic we are going to learn in a what it is very brief way in that aldehyde and ketone also. Aldehyde ketone also we are going to learn, and even in alcohol topic also we are learning, and it's very important question. Hope you understand this question. Okay, we'll go for some other important question. Now, the next question, it is name the dehydrating agents used for dehydration of alcohol. Dehydration of alcohol, what is the product you will get it? You are getting that alkene product only. Why? Because removal of water. Dehydration means what it is? Removal of water. So, what are the dehydrating agent? So, it is concentrated H2SO4, that is sulfuric acid, and concentrated orthophosphoric acid H3PO4, and next one anhydrous zinc chloride. These are the important. As I mentioned, anhydrous only you people will say it is zinc chloride because it's removal of water. It helps to remove that water. Yes, dehydration of alcohol converts. Here you are getting alkene, that is the product, and it's very, very important. Repeatedly they are asking that question. And the second question, next question, name the product formed when alcohol react with carboxylic acid. This is also interrelated, only that reagent only we are using here also to convert. So what is the product? It's first and foremost carboxylic acid and alcohol, you are getting ester formation. So what is it, what we are using in between here? Dehydrating agents, removal of water. Here also removal of water only. Alcohol, ROH combined with RCOOH. Carboxylic acid, in between what is it? Concentrated H2SO4, removal of water, and removal of what I just mentioned here. So what you will get it? R O O R R dash. Okay, okay. So this is what it is. Ester formation. Ester formation. So ester for fruity smell. That and all. I think you might have heard about that. Okay, so this is the what it is, alcohol and carboxylic acid combined, you are getting ester formation. And next one, it's very, very important, repeated and easy question. What is Lucas reagent? Everybody knows it is what it is. Concentrated HCl. Yes, I can hear your voice. Concentrated HCl and hydrous zinc chloride. Yes, thank you. What you are saying, I can hear. See, concentrated hydrochloric acid and anhydrous zinc chloride. Okay, so here this is a Lucas reagent. What purpose we are using to identify that the alcohol, whether it is a primary, secondary, tertiary. In our last session, I think we have gone through this. Tertiary alcohol, immediate turbidity formation, and secondary alcohol after 5 minutes. Primary alcohol, after heating only you will get that turbidity. So in that way you can classify that alcohol, you can identify the alcohol which is using. Now one more question. Ethyl alcohol, give one test for ethyl alcohol. So you can write what it is. Lucas reagent also you can identify whether it is alcohol, primary alcohol. What is it, primary or secondary or tertiary? Ethyl alcohol, it's a primary, secondary or tertiary? Please write it in my comment box. Hope you understand all these questions. Come on, let us go for some more important questions. The next very interesting question it is, Name the product formed when primary, secondary, tertiary alcohol passed through heated copper. It is a catalyzed. And it is one more thing I wanted to mention, dehydrogenation formation. So dehydrogenation means removal of hydrogen. Now they are asking primary, secondary, tertiary, and it is important question also. Come on, let us go for the primary. CH3, CH2, OH combined with, that is actually not combined with it, when you heated with it, when you heated copper, when you pass through that primary alcohol Cu at 573 Kelvin, dehydrogenation reaction takes place. So dehydrogenation means what it is? A removal of hydrogen. So what is the product you are getting? You are getting aldehyde, CH3 CHO. So how many carbon is there? According to that aldehyde, you will get it. In our last previous session, we have discussed this point, and I will put it in the description box. Hope you will remember and you just to watch it. Okay, now this is the primary and secondary alcohol. So secondary alcohol CH3, CHOH, CH3. And the same way Cu 573. When you pass the secondary alcohol to that red hotter, the copper catalyst, so what you will get it? CH3, C double bond O, CH3. You will get ketone. This is aldehyde formation. This is ketone formation. And again here what it is? Hydrogen will be removed. Okay, hydrogen will be removed. Dehydrogenation means removal of hydrogen. Now third one, tertiary. So tertiary means CH3, C here CH3, here OH, here CH3. Tertiary alcohol 1, 2, 3. Steric hindrance. Okay, now here when you pass through that copper acts as a catalyst at 573 Kelvin. So what happened? Here hydrogen is connected. Here also hydrogen is connected with OH. Here also hydrogen connected with OH. Whereas here it does not have hydrogen connected with OH. So hydrogen it cannot be removed. So here dehydrogenation reaction won't be taking place. Dehydration it will be takes place. So dehydration means removal of water. Here I'll mention that dehydration. And these two are dehydrogenation. Dehydrogenation. Please remember these points, children. It's very, very important. Dehydration. So, dehydration means removal of water. What happened from here? One hydrogen will be removed, then it will become CH2. So, here CH3, C here CH3, double bond CH2. See here, this is 2 methyl, 2 propene, 2 propene. See, remember this dehydration means alcohol converted into alkene, propene. Remember this. In this way also you remember dehydration takes place means alcohol converted into alkene, propene, double bond, removal of water. You please remember all these hint that will be helpful. Tricks and tips always will be helpful to understand the concept. Okay, now this is aldehyde and this is ketone and this is primary alcohol gives that aldehyde, secondary alcohol gives that ketone, and tertiary alcohol it does not have that hydrogen connected with carbon, so it gives alkene. So what formation it takes place? Dehydration formation it takes place. Whereas here primary and secondary you are getting dehydrogenation. Hope you understand this point very clearly. Yes, the next question. Name the product formed when ethyl alcohol heated with excess of H2SO4. The same point only here also it will be repeated. Alcohol, when you are heating with that excess of dehydrating agent H2SO4, alkene only. So ethyl alcohol only they have given CH3, CH2, OH. So water removal of water. Here H2O and here what it is? The just I just put it that arrow mark excess of H2SO4 acid catalyzed. So naturally you will get ethene CH2 double bond CH2. Yes, mechanism also we have gone through this. I will put it all these concept based videos. I'll put it in the description. So please watch it. So that will be helpful for you. Hope you understand. And this is very important question. Please note down all these are all important questions only this session what we are learning. Okay. Hope you understand. Then next some more questions. The next question, give the order of primary, secondary, and tertiary alcohols of what it is dehydration reactivity series only they are asking. And see dehydration see number of times they are asking that question. I think you will come to get that idea, that weightage point where you have to concentrate. Yes, come on, let us go for the reactivity series order of the primary, secondary, tertiary means of course it is tertiary, secondary, and primary only. So tertiary we can put it like this way: R, C here R, and here also R here carbocation formation. So here the same way here R secondaries, here R and hydrogen. This is also carbocation formation, and here what it is R, here hydrogen, and here what it is hydrogen, and here carbocation formation. So it is tertiary, it's greater than secondary, and it's greater than primary. You know this is AI 0 1. It's very important. I just wanted to mention that. Okay, now this is very easy and simple. The next one, distinguish between the propane 1 all and propane 2 all. This is also a very important question to be noted. Yes, propane 1 all CH3 CH2 CH2 OH, whereas here CH3 CH2, yeah, CHOH CH3 isopropyl alcohol, and this is straight chain structure, this is branched chain structure. And the next one, how to identify easily, see Lucas reagent, it is very easy to identify. Propane 1 all, this is propane 2 all. Okay, Lucas reagent is what it is: concentrated HCl and anhydrous zinc chloride. Okay, ZnCl2. Okay, now suppose primary alcohol, this is secondary alcohol, right? So primary alcohol, you just take it that in the test tube alcohol, and you just add the what it is Lucas reagent. Lucas reagent, what happens? Secondary alcohol, it will not, primary alcohol, it will not react at all. Okay, unless and until if you give heat, then only you will get the turbidity formation. Whereas here the same test tube with the secondary alcohol, you just take it that secondary alcohol in another test tube, and you just add that Lucas reagent you just add. Okay, so what happened? This also first 5 minutes it will take slow and steady like wins the race. So after 5 to 10 minutes, minimum 5 minutes, it started reacting. So after 5 minutes, slowly it started what it is turbidity formation. But tertiary, it fast, responding very fast. Whatever we say, at once it will act. So that is the tertiary. Now this is secondary. Secondary, after 5 minutes it will react. And primary, it is very slow and dead slow unless and until we give that external force, then only it will react. That is what it is primary. And this is primary, and that is secondary. Propane 1 all, propane 2 all. Okay, hope you remember this and this important question. Please note down every question, whatever we have gone through. Those questions are very important. Hope you understand clearly. The next question, very interesting question, and these also give reason. A mixture of ethyl alcohol and water cannot be separated. easily, that is through distillation method. We cannot separate at all. Why? Because it is a azeotropic mixture. Azeotropic mixture. Okay, azeotropic mixture means what it is? Constant boiling point. Constant boiling point. Constant boiling point means both are having a same boiling point, so we cannot separate it easily through distillation. If it is different boiling point means through fractional distillation we can take it out. One it is there in another, like fractions of second we can remove one compound from other. But whereas here it's a constant boiling point, both are having a same boiling point, so we cannot separate it very easily. Okay, now next question. Really, it is very interesting. As you are looking that question only, you may get timid, but it is so easy one. And actually, it is related to aldehyde and ketone. But in this chapter, they have given, and it's very important. Important question only. I brought it to you all. Okay, which one of the following will most readily to be reacted hydrated in acidic condition? So they have given all these points. Yes, so in this mainly, as you are looking at the compound only, don't get timid. It is beta hydroxy aldehydes or ketones are available together. You just check it. Okay, now first one, beta hydroxy group it is there, and what it is, beta keto group also it's available. And here only one hydroxyl group it is there, only one keto group it is there, and one hydroxyl group up and down. It is not so easy. Here, I would like to provide a simple trick for you. Beta hydroxyaldehydes or beta hydroxy ketones readily undergo what it is, dehydration. Dehydration means removal of water. Easily it will remove that water. Whereas here only one OH is there. Here one O it is there, the other one. So it cannot go easily to identify. And even one here and another alternative way. So easily it will undergo dehydration, removal of water. Yes, that is one point. So what happened, it forms dehydration and easily you will get unsaturated compound of alpha beta unsaturated compound of aldehydes or ketones formation. It will take place. I'll tell you once again, beta hydroxy aldehydes or beta hydroxy ketones readily undergo dehydration. Why? Because removal, easily it will remove that water and it form alpha and beta, what it is, unsaturated aldehydes and ketone formation takes place. Actually, this is aldehyde and ketone chapter only, but in this chapter they have given this question. So I have brought it all these important questions from that exercise point. I have brought it. Okay. Hope you understand. So whenever you see this compound like that, if they are asking such kind of question, you just check where it is, where there is alpha hydroxy, beta hydroxy, aldehydes or ketones. Like you just check it, which is readily undergo dehydration. Dehydration means removal of water. Is it possible to remove the water? Is it possible to remove the water? Is it possible to remove that water? In that way, you just think it and use the trick and you can identify. So this will be answerable. So this will, you will get the formation of what it is, alpha, beta, unsaturated of aldehydes and ketones. Hope you understand very clearly. That next question, okay, 15th question. Yes, name the best reagent to convert cyclohexanol to cyclohexene, all to ene. That means alcohol to alkene. So what is that? Dehydration only, water removal. Okay, yes, cyclohexanol, no, cyclohexanol converted into cyclohexene. Yes, cyclohexane. So, what is the best reagent to convert? So, dehydrating agent only. So, what it is? Concentrated H3 PO4, orthophosphoric acid only, is the main reagent which convert cyclohexanol to cyclohexene. Hope you understand very clearly. This is cyclohexanol and this is cyclohexene. And this is very, very important question. Hope you understand all the question today, whatever we discussed. Thanks for watching. This reaction comes under dehydration only. So removal of water from hydrogen, here one hydrogen, so and from here OH. So automatically it removes that water. What it is? Alcohol to alkene. Please remember in that point, that concept. See, direct alcohol means you will remember. But this is cyclo compound. Any tricky question comes also. You please remember the tricks and concepts so that you will crack out very easily. Thanks for watching.